Find the interval and radius of convergence for the given power series. So we have the sum from k equals 1 to infinity of 1 over the quantity k squared plus k times the quantity 3x minus 1 to the k power. So what we'll do is we'll first look at the ratio test. We'll look at a limit as n goes to infinity of the absolute value of the ratio of, well, first we'll take this term in the series evaluated at n plus 1. So we'll have 3x minus 1 to the n plus 1, and then we'll divide that by n plus 1 squared plus the quantity n plus 1. And then we'll look at the ratio of that to the term evaluated at n. So we'll have 3x minus 1 to the nth power divided by, well, n squared plus n. And of course, we'll look at the limit of the absolute value. So this will become the limit as n goes to infinity of, well, 3x minus 1 to the n plus 1 over 3x minus 1 to the n. That will simply be 3x minus 1. And when we look at the ratios of these terms in the denominators, what will happen is those will become n squared plus n over, well, this one on top will go into the bottom, and that will become n. When we square n plus 1, we'll get n squared plus 2n plus 1, and then we'll add the n plus 1. And of course, we should note that the terms involving the n's, these will all be non-negative because n will be a natural number. So we can bring those to the outside. So we're going to get the limit as n goes to infinity of, well, we'll have n squared plus n over, well, when we simplify the denominator, we'll wind up with n squared plus 3n plus 2, and that will be times the absolute value of 3x minus 1. Well, if we look at the limit as n goes to infinity of n squared plus n over n squared plus 3n plus 2, that will simply be 1. So this will simply become the absolute value of 3x minus 1. And if we want this to be absolutely convergent, so we want to know where will this be absolutely convergent, well, that will happen when the absolute value of 3x minus 1 is less than 1. So what we'll do is we'll try to determine the values of x for which this will be true. So we'll let 3x minus 1 be between negative 1 and positive 1. And if we add 1 to all three parts, we get 0 less than 3x less than 2. And dividing all three parts by 3, we'll find that x will be between 0 and 2/3. So the series will be absolutely convergent from 0 to 2/3. So we'll now just need to consider what's happening at the endpoints. So if we consider x equals 0, then if we look at the series where we have negative 1 to the k power over k squared plus k, and of course we take a sum from k equals 1 to infinity, this will converge by the alternating series test. So that means that this will be valid when x equals 0. And at x equals 2/3, what we'll do is we'll consider the series where we have the sum from k equals 1 to infinity of 1 over k squared plus k. And this will also converge. It will converge because the series where we have the sum from k equals 1 to infinity of 1 over k squared, that will converge. So that means that our series converges on the closed interval from 0 to 2/3. And our radius of convergence, in this case, it's going to be 1/3. So our radius of convergence, r, is going to be 1/3. So we can see that this power series, it converges on the closed interval from 0 to 2/3, and it has a radius of convergence of 1/3.